Hello everyone, my name is Aiza Camporedondo and I will be discussing the mole concept, specifically the on how to perform the mole to mole, mole to and mass to mass computation. So let's start with the mole to mole calculation. This calculation is used to find the number of moles of one substance when you know the number of moles of another substance using the molar ratio from the balance equation. Right here we have the general formula of mole to mole. So moles of substance B is equal to moles of substance A multiplied by the moles of B over moles of A. Let's proceed with the problem solving. Given the reaction, 2 moles of hydrogen gas is added to 1 mole of oxygen gas, produces 2 moles of water. So if you have 4 moles of hydrogen gas, how many moles of water are produced? Hmm. Okay, so first thing we need to do is to use the general formula of mole to mole calculation and substitute this formula, the given value. Uh, okay, so the substance B right here is the product. Okay, the moles of water is equals to the 4 moles of hydrogen gas multiplied by 2 over 2. So what is this? This is actually the coefficient or the ratio of both substances. We have here the hydrogen gas and the water. So how many coefficients or how many moles um has the hydrogen gas? So we have right here the 2 moles. And on the other hand, for water have also 2 moles. That is why there are 2 moles for water and 2 moles for hydrogen gas. And since there is 2 moles of hydrogen gas right here and the moles of hydrogen gas right here, this can be actually, crashed out. And that leave us with the moles of water. So 4 moles of hydrogen gas multiplied by 2 moles of water is equals to 8. 8 divided by 2. That would leave us with 4 moles of water. And that is how we get the moles of water from the 4 moles of hydrogen gas. Okay, so let's have another example. Given the reaction methane, 1 mole of methane is added with 2 moles of oxygen gas, produces 1 mole of carbon dioxide and 2 moles of water. So if you have 3 moles of methane, how many moles of carbon dioxide will be produced? Okay, so right here, first we need to look at the ratio of both substances that we need to, that are related and we need to find. Okay. For methane, there is only one coefficient. Okay. Even though there is no number right here, it is understandable that there is number one right there. One coefficient or 1 mole of methane. Okay. On the other hand, for carbon dioxide, there is also 1 mole of carbon dioxide. Therefore, if we're going to um hmm, if we're going to use the formula, moles of carbon dioxide is equals to the moles of methane right here, that is in the given, multiplied by 1 mole of carbon dioxide is over 1 mole of methane. That would leave us with 3 moles of carbon dioxide. Okay, I hope you still get it. Let's proceed with the second calculation. That would be mole to mass. This calculation is used to convert moles of a substance to mass or vice versa, mass to mole, using the molar mass of a substance. We have here the general formula of mole to mass. Mass of a substance is equals to the moles of the substance multiplied by the molar mass of the substance. Let's proceed with the calculation. So if you have 2 moles of water and the molar mass of water is 18.02 grams per mole, how many grams do you have? Using the general formula, we need to substitute all this the actually the given value. So the mass of the hydrogen, the water, is equals to the 2 moles of water also multiplied by the molar mass of the water, 18.02 grams per mole. And the moles right here will be, crushed out. That would leave us with the grams of the water. And that would be 36.04 grams of water. Okay, let's proceed to another example. How many grams of carbon dioxide are in 4 moles of carbon dioxide? Okay, in this case, we need to get first the molar mass of carbon dioxide. If you have noticed right here, there is 12.01 gram per mole. This molar mass is actually the molar mass of carbon, not carbon dioxide, only carbon. Now, right here naman, this is 16.00 grams per mole. This is the molar mass of oxygen. How about the two right here? These represent the subscript or the number of atom of the oxygen. That is why the oxygen should be multiplied by 2 because there are 2 atoms of oxygen. So 2 times 16, that would be 36 plus 12.01 gram per mole, that would be 44.01 gram per mole. That is the molar mass of the carbon dioxide. That is not the final answer yet. Okay, let's proceed by using the general formula of the mass to mole to mass. For the mass of the substance is equals to the moles of substance multiplied by the molar mass of the substance. So we all now have the value that are needed, moles of the substance and the molar mass of the substance. We just need to substitute those values for moles of carbon dioxide multiplied by 44.01 grams per mole, or the molar mass of the carbon dioxide, we will get the mass of the carbon dioxide because the mole right here is being crushed out. That leaves us with 176.04 grams of carbon dioxide. Okay, so let's proceed to the third calculation. We have here the mass to mass calculation. This is used to convert the mass of one substance to the mass of another substance based on a balanced chemical equation. So I really want to emphasize first that in solving the mole to mass, or you need in using this calculation, the three calculation, mass to mass, mole to mole, and mole to mass calculation, we need first to verify first. Verify. We need to make sure that the chemical equation are balanced because there are problems kasi that the atoms or the molecules, the number of atoms of an element in a reactant is not the same with the number of atoms in the product. That is why it's really important to balance the chemical equation first before proceeding to this calculation. Okay, so we have here the general formula of the mass to mass calculation. We have here the mass of the substance B is equals to the mass of substance A over molar mass of substance A multiplied by the moles of B over moles of A multiplied by the molar mass of B. Okay, let's have the problem solving. So given the reaction, we have here the nitrogen gas is added to the 3 moles of hydrogen gas produces 2 moles of ammonia. Okay, if you have 50 grams of nitrogen gas, how many grams of ammonia will be produced? Okay, based on the what do you call it? Based on the balance equation, because actually this is balance equation. Um, the moles of nitrogen right here is actually 1, while the ammonia has 2 mole, and that would give us a realization that the ratio of the two substances is 1:2. Okay, 1:2. Okay, please take note of that. Now, first things first, we need to convert the mass of the nitrogen gas to moles. So right here, we need to get the molar mass of the nitrogen first. Actually, these smaller mass can be actually found in the periodic table. So there is no need to ask for Google where you can find the molar mass. So the moles of nitrogen gas is equals to 50 grams right here, that is given, divided by the molar mass of the nitrogen gas, that would be 28.02 grams per mole. But actually the nitrogen has the molar mass of 14.01 gram per mole. Now, why is it 28.02 grams per mole? Because of Yes, because of the number of atom of the nitrogen. So that is why 14.01 gram per mole, that will be the molar mass of the nitrogen, multiplied by 2. Because there are 2 atoms of nitrogen, and that leaves us with 28.02 grams per mole. And since this is, crushable, so we need to crush this one, that leaves us with 1.783 mole of nitrogen gas. This is not the answer yet. Okay, for the second, step on how to get the mass of the other substance, we need first to know the ratio. This is what I was talking about earlier. So we all know that the ratio of the nitrogen to ammonia is actually 1:2. That is why the mole of the nitrogen gas here is multiplied by 2 moles of ammonia over 1 mole of nitrogen gas. We need to crush this out with this one, and that leaves us with 1.783 mole of nitrogen gas multiplied by 2 mole. That would be 3.566 mole of ammonia. But that is still not the final answer yet. Last steps is to what do you call this? To use the molar mass of the ammonia. Molar mass of the ammonia. So right here, says nitrogen actually has 14.01 grams per mole, and the hydrogen has 1.008 grams per mole times 3, because there are 3 atoms of hydrogen, that leave us with the molar mass of ammonia. That would be 17.03 grams per mole. And we're going to multiply that one to the moles of ammonia right here. 3.566 moles of ammonia multiplied by the molar mass of ammonia, that would be 17.03 grams per mole. That leave us with the mass of ammonia, 60.7 grams of ammonia. Because the moles right here can be crushed out. Okay, so we're down with one problem. Let's proceed to another problem. Given the reaction, 2 moles of sodium is added to 1 mole of chlorine, produces 2 moles of sodium chloride. How many grams of sodium chloride are formed from 10.0 grams of sodium and excess chlorine. Okay, so in this case, we need to get the molar mass of, we all know the molar mass of sodium now. That would be 22.99 grams per mole. That is for sodium. Now, using this one, we need to multiply that one to the grams of sodium. And 10.0 grams divided by 22.99 grams per mole, that leave us with, this would be crushed out, it will leave us with the 0.435 mole of sodium. Now, in this case, since we're going to, you know, convert this one into the grams of the sodium chloride, what is the ratio of the sodium to the sodium chloride? That is 2:2. Therefore, the moles of the sodium is equal to the moles of sodium chloride. Now, if we're going to, follow the formula later, the earlier, actually, you will arrive with the same value of mole here in the case of sodium chloride. So yes, we're going to use that one. 0.435 moles of sodium chloride. Sodium chloride. Because the ratio is the same. So we can conclude that the moles of sodium chloride is the same with the moles of sodium chloride. That is why right here is the same with the moles of sodium. And this is the moles of sodium chloride. Now, the molar mass of the sodium chloride is, we need to add the what do you call this? The molar mass of the sodium and the molar mass of the chlorine, and that we will get the molar mass of the sodium chloride, 58.44 grams per mole. Now we need to crush this out the mole, and we'll arrive to the answer 25.4 grams of sodium chloride. And that would be the final answer in this problem. Okay, so that's the end of our discussion. But before we end, I must, let's sum it up. Now, multiple calculation, please remember that you need to use that this is used, that this uses the mole ratio from the balance equation to find the moles of one substance from mole to of another. Mole of one substance from the mole of another. We have the general formula here. Moles of the substance B is equals to the moles of substance A multiplied by the moles of B over moles of A. The second calculation is mole to mass. This is used to convert the moles to mass or mass to moles using the molar mass of the substance. So mass of the substance is equals to moles of the substance multiplied by the molar mass of the substance. Okay. The next calculation we have here, the mass to mass calculation. It is used to convert the mass to moles, use the mole ratio from the equation, and convert it back to the mass of another substance. Now, the mass of substance B is equals to the mass of substance A over molar mass of A multiplied by the moles of B over moles of A multiplied by molar mass of B. And that would be the general formula of mass to mass calculation. And that's it. Thank you so much for listening, everyone. I hope you have a good day. Bye-bye.